702 and Cape Talk.
The Naked Scientist.
And we started with a fantastic announcement. We have a special show next week, Thursday, just before the Easter weekend. Dr. Chris Smith, the Naked Scientist, is going to be in South Africa and will be joining us here at 702 for a special live show in front of an audience. I don't know who wrote that in there. It is superfluous. Live means in front of an audience. If you'd like to be part of the audience, go to our website, 702.co.za. This is one of our most popular features. I'm sure many of you would like to meet Chris and see him do his thing live. You have met him before, a couple of you. Here's a chance for some of you. Space is limited, so please go there very quickly. 702.co.za. Next week, Thursday, we're going to be hanging out here with Chris, who is traveling to South Africa. Good morning, Chris.
Can I come to the event next week? That sounds good.
Yeah, well, if you're not there, it's not going to happen. Otherwise, I'm going to have a cup of tea pretending it is an experiment. The science story this week is one that fascinates me because a lot of people are desperate for breakthroughs when it comes to research related to the eye in general, and in particular, of course, treatments for macular degeneration.
Well, this is a very exciting paper. I first met the scientists behind this. I met one of them in Australia when he was speaking at a conference that I was also speaking at. This was about 2 years ago, and he showed me what they were going to do, and I was just jaw-droppingly impressed. And now the paper describing this and actually demonstrating that it works in patients with eye problems has just been published this week. So what have they done? They've tackled the problem, which is macular degeneration. Now, the macula is the most sensitive part of the retina at the back of your eye. And as we get older, a high fraction of people lose cells in the back of the eye, and some of them develop this condition, macular degeneration. And what happens in macular degeneration is that the retina becomes unhealthy. You can sometimes get bleeding into the retina. That's so-called wet macular degeneration. You can also get a sort of dry form of the disease where other rubbish builds up at the back of the eye and kills off the photoreceptors, the rods and cones. Now, what this group at Moorfields, Pete Coffey and Lyndon de Cruz and their colleagues have published this week in the journal Nature Biotechnology is they have made from stem cells a patch, like a repair patch, and a special tool to insert it. They can put this repair patch in behind the retina. It's new tissue called retinal pigment epithelium. It sort of integrates itself into the back of the eye and takes over the job of cleaning up the debris and the other waste products that would otherwise be poisoning the retina in people with this condition. They've done this in a small group just to prove safety who have macular degeneration. And as well as proving it was safe, they didn't get any adverse outcomes on the whole. What it did do is to restore vision. In one case, a lady went from taking about a minute to read one word with a magnifying glass to doing 80 words a minute. So the results look very, very encouraging. They're very excited about this, and the next stage will be to do more trials in more people and actually look at how efficacious this is, but it looks really encouraging. So there is hope here for a disease which affects hundreds of thousands of people in every country, and which we're going to see more and more of as the world becomes more affluent, because we're going to start seeing more diseases of affluence. Diseases of affluence are diseases where people live long enough to get them. And in many countries, because life expectancy is rising, more people are getting more of these diseases of longevity all the time, and macular degeneration is a really, really common one. So this is great news.
Absolutely. Go to Centurion. Tommy, you've got an interesting question. Go ahead.
Hi, you Sylvia and Chris. My question really is, if I am a recipient of organs, somebody has donated organs to me, when I pass on, can I then elect to have, or can my family then decide to give, those organs to another donor?
Lovely question. Thank you, Tommy. Ubuntu and organ donation. Chris?
When we donate an organ from one person to another, unless you have got an identical twin, which actually the first renal transplant that saved a life, what was done in the context of identical twins, but unless you've got an identical twin who's genetically the same as you, your body is always having to tolerate an organ from someone who's not your direct genetic match. This means two things. One, that person has to take drugs to suppress the immune system a bit. And two, the immune system will still regard the foreign organ as a threat. So even though the organ is a close match, it's not a perfect match, and there'll be this slow damage to the organ because of immune rejection and also the drugs that are needed to suppress the immune system. So therefore, the person would find that the organ will not last a lifetime as it would do normally. It might last, in the case of, say, a heart transplant, 10 years, in some cases, very luckily, 20 years. Kidney, much the same. So the organ that you would die with, having been transplanted with, would probably not be attractive to another recipient because it wouldn't necessarily have that many years left in it. So we like to transplant very healthy organs which are going to give the best service, because having an organ transplant is such a serious operation, uses a lot of resources, it's very unsafe, very, very risky for the person who's having the transplant. And for that reason, you want to give them the best chance that this process is going to work. So you want to give them the healthiest organ you can. And this is why we have a terrible shortage worldwide of donor organs, because people who are healthy don't want to give up their healthy organs if they can help it. In the case of kidneys, it's a bit different because you've got two of those and you can get by with one. So we do living transplants with kidneys. But on the whole, you wouldn't want to pass on your kidney if you've had a transplant to another person, because it probably wouldn't give them very long, certainly not as long as if you gave them a healthy organ up front.
Here's one from Twitter. Felicity says, please ask the Naked Scientist, how come one of my armpits always has a stronger odor than the other one?
Well, hello Felicity. The possibility is that there's a bit more sweat coming out of one side than the other, because the way that we sweat is we have sweat glands, which are eccrine and apocrine glands underneath the skin. These filter out the plasma from blood, put it down ducts and add other things to it like salts and other chemicals, which then the ducts from these sweat glands open onto the skin surface and apply a thin film of sweat there, and these other chemicals, including the things that make you smelly a bit. And those are your pheromones, which attract other people. Thriving also in sweaty places are bacteria, and bacteria and other microorganisms in these places use the water. They also use dead skin and other things they find there to eat, and as they eat, they also produce whiffy products, which are the smells that you get. Now, the distribution of sweat glands is not 100% uniform and homogeneous across your body. In some places, you will have a higher density of sweat glands than others. You will also have different blood vessel networks there, and the innervation, the supply of nerves to those areas, will be slightly different from one side over the other. So it's possible, just by chance, that what's happened to Felicity is that the density of sweat glands responding to the nervous system, perhaps the density of blood vessels and the density of nerves supplying that area, slightly differ from one side to the other, just by chance, and that's why there is an asymmetry in the rate of sweating. I'm surprised she can actually notice. It might be something else that's responsible for this, such as you notice it more because of the position you sit in, or you notice this when you're driving and one side of you's in the sunshine more than the other, so you tend to feel hotter and sweatier on one side than the other. So it's important to rule out all the possible coincidences first, and then conclude what I've suggested as one other possibility.
Okay, we've got a lovely question on the SMS line as well, then we'll come back to the phone questions that we have for you. What is the difference between a sea and an ocean? Asked Tuso.
Hello, Tuso. Well, on the whole, we tend to use the word sea when we're talking about something a bit more diminutive. I don't know if there's a proper geographical term for this, but we tend to talk about the sea as a fairly smaller, well-circumscribed patch of the Earth's watery surface, whereas an ocean, there are not so many of those. We've got Pacific, Atlantic, Indian, Southern, and so on. Those are vast bodies of water. So I think ocean is used to describe a vast body of water, sea a more localised or geographically localised patch of water. But seas can be pretty big as well, of course. There are also inland seas, but we don't have any inland oceans.
Jean, good morning.
Good morning, Chris. I have a neurological condition which is unusual. My brain seems to receive information or messages a few seconds later than the average person. I am aware of this because when I'm in a group situation and there's everybody laughs, then I will laugh that much later. And also when people clap at a concert, I will clap that much later as well. Could you please comment on this for me?
Hello, Jean. Very interesting. I've not come across anyone who's quite said anything like this before. But remember that everybody is living in the past. Because, in fact, people have done experiments where they have measured a person's brain activity and presented stimuli to them and then ask them to make a decision off the back of the stimuli that are being presented. And what you can show is that people show a change in their brain activity more than a third of a second before they actually do something or tell you they've become consciously aware of this happening. The experiment that first showed this was a set of individuals were given the controller for a slide projector. If you remember an old-fashioned 35mm slide projector, they were given the remote controller and told to show themselves some pictures. What the researchers were doing secretly was recording the brain activity from these people, and when they saw the brain activity change, which indicated the person was planning to make a movement to turn the slides forward, they automatically then advanced the slides. The remote controller wasn't even connected. And the subjects were all surprised because they said, do you know, it's really strange. It's as though the slide projector knew what I was about to do. So in other words, we're all living in the past. We're all living in a world that's presented to our consciousness a third of a second after it actually happened. And just the time it takes your eyes and your visual system to process something is about 150 milliseconds. So a tenth of a second goes by or more between something actually happening to you and then your brain becoming aware that it's watching or seeing that thing. So we're all living in the past, and it may well be that you're just a bit more conscious of it than someone else.
20 minutes after 10, if you've got a question for the Naked Scientist, she's still with us for another 10 minutes. 011 8830702 in Johannesburg, in Cape Town on 021 446 0567.
702 and Cape Talk.
The Naked Scientist.
Jeremy, put your question to Chris.
Hi, Eusebius and Chris. My question relates to the expansion of the universe. If the universe is expanding, what is it expanding into? The example of a balloon being inflated doesn't seem to work for me because the balloon is expanding into air. Presumably the universe is expanding into nothing. Therefore, nothing must be something.
Thank you, Jeremy. An old chestnut, a lovely question, though. I love
yeah.
returning to it because I can never remember the answer perfectly. Chris?
Well, this is the thing that Stephen Hawking, who unfortunately died last week, spent a lot of his time grappling with. What is the universe? What is it coming from? Where's it going to? And why is it expanding? And if it's expanding, what is it expanding into? And really, the balloon analogy explains some aspects of this, as Jeremy alludes to. You think of the expanding universe as a bubble blowing up, and the surface of the balloon is where we are, and we look in all directions and we see everything getting further away because there's more balloon surface between us and the other objects on the surface of the balloon. But the thing is, as Jeremy points out, a balloon is an entity expanding in front of you into another entity, which is air. If the universe is doing that, and the universe is everything, then it's very hard to grapple with our view of the universe in terms of our human brain's ability to model the universe, what it is expanding into. One of the things that Stephen Hawking published just before he died and has submitted to another set of journals, I'll rephrase that. One of the things that Stephen Hawking did just before he died was to send off a paper for consideration by a journal to look at the question of whether our universe is the only universe, because there are a number of things which we can't reconcile with our model of the Big Bang. And that is that it should have spawned not just one universe, but many parallel universes. And maybe there are millions or an infinite number of universes, all like this one, all stacked up side by side. So the answer, the posh answer to Jeremy's question is we just don't know. But one possibility is that actually we don't understand the multi-dimensional nature of the universe around us, and in fact it's expanding into dimensions that we have no concept of, and therefore it makes perfect sense to the universe to do that, but it doesn't make any sense to us with our view of the way that space works.
Bucks, what is your question?
Good morning. No, I haven't got a question. It's about, I'm just going back a bit, the answer that Chris has given regarding the eyes. I had an operation, 2 operations on my eyes. I had 20% eyesight. And I went for 2 operations 3 weeks apart. And my eyesight from 20% to 100%.
Wow.
And I don't know if it's the same thing that he spoke about. I mean, I'm not a medic, but from 20% to 100%.
That's wonderful.
Yeah, I tell you what, it's magic. And It's unbelievable. You're in another world.
So not a question for you, Chris, but that's wonderful success there with some surgery related to the retina.
Well, I suspect it could be a cataract operation, because cataracts are the most common eye pathology in the world. Even the Romans 2,000 years ago were taking cataracts out. If you look at Roman digs and things that have been recovered from ancient Roman archaeological sites from 2,000 years ago, you can find medical instruments that were clearly based on the size, shape, and also things they wrote down and documented. They knew about cataracts, and they were taking cataracts out to restore some semblance of vision in people. It's probably the most commonly practiced and probably the most successful medical operation in terms of its benefit to an end user for minimal risk that we can do.
Solly, we have you back now. What is your question?
Morning. My question is that why whenever you've got a condition in your body, for an example, a flu or toothache, it becomes severe at night. Then during the day, it's mild. Thank you.
Chris?
Yeah, luckily I've never had toothache. You know, I've got to my ripe old age of into my 40s, and I've never had a mouldy tooth. I've never had a filling. I've always looked after my teeth. I'm very lucky. But I do understand from those around me that it can be really quite excruciating. I don't know why it would necessarily become worse at night. It might feel like it's become worse at night, and this may well be because when you're up and about during the day, there are lots of things to distract you. You're active, you're busy. When you're lying down and trying to sleep at night and something is keeping you awake, A, it's very irritating because it's keeping you awake. B, you're tired and you want to sleep, and your ability to psychologically surmount challenges and use your resolve is weakened when you're tired. And that's probably also part of it. So I think it's probably mainly a psychological element to this. There's not really any evidence, I don't think, that neurologically anything's changing at night. So I think probably it's that your resilience is down because you're knackered and you notice more.
That makes sense. Ryan, good morning to you. What is your question?
Good morning. Yes, I've seen a few videos on Facebook recently where in the U.S. they are burning snow, and instead of melting away, it's getting dark, black, and it's got a plastic smell. Any idea of why that's happening? They're relating it to something being sprayed in the skies?
I haven't the faintest, but Chris knows everything.
I've not seen the videos and I've not seen the story, so I can't comment on that specifically. If you can send me a reference to it, I'd be happy to talk about it. I thought what you were going to talk about when we first started listening was these things called methane clathrates, which is that fishermen occasionally catch in their nets in certain places on Earth these big ice cubes, and they're dredged up from the ocean floor, and they look like a big chunk of ice. But in fact, if you put a flame to them, they will burn as though they're a big fire lighter or a big barbecue lighter. And actually what happens is that under high pressure at the bottom of the sea, where methane, natural gas, seeps out from the sea floor, under this sort of pressure, you can push water into an interesting configuration called a clathrate. And this clathrate forms a watery cage where you get a number of water molecules, 20, 40, certain numbers of water molecules that line up into a special configuration with a small cavity in the centre of this cage of water molecules. And that cavity is the right size and shape to hold a methane molecule. So you end up with these big ice cubes, which are these watery cages loaded with natural gas, which is why if you light them, they will burn. Now, it may be that people have been doing something in America, seeding clouds or something, and that's doing something different. I would need to see the reference, though, to comment on that, because I haven't seen the story. I'm sorry.
Tsepo, good morning. What is your question?
Hi, morning. How are you?
We are well, Tsepo. What is your question, quickly?
Yeah, my question is that I see in Kenya there is a seismic movement of the earth that might cause what I call, I don't know, I just personally, what I might call African Ocean. They say Africa is going to be divided into two, and it was not an earthquake. What is the cause of that movement? I will listen on the radio.
This is, I think you're referring to the Great Rift Valley. And the Earth is divided up its surface into tectonic plates. And these tectonic plates have continents on them, continental crust. They also have oceans on them, seafloor. and they are continuously jockeying for position and moving round. And over millions of years, because these things move very slowly, they reposition all of the land masses, where the oceans are, the boundaries between these plates. They're all moving independently. And for instance, the one between America and Europe moves at roughly the rate that your fingernails grow. The plates that are near Taiwan over in China move much faster. They're moving at, say, 20 centimetres a year in some cases. So these plates moving either are moving apart from each other or they're moving towards each other. If they're moving apart from each other, you get a rift or a rip in a patch of land or the Earth's surface, and things move further apart. If they're moving together, then they buckle up and push land upwards, and you can get mountains, volcanoes, and what we call subduction, where one plate's swallowed up underneath another one. All these things are possible, and there is one of these configurations in Africa, and it's the Great Rift Valley. I think that's what's being referred to.
Well, next week we'll see you in the flesh, Chris. Any idea what fun we're going to get up to?
Well, I understand we've got to make a cup of tea, haven't we? Because we've got to solve the mystery of when you put the milk in the tea, with or without the sugar. We'll be doing that. I'm dreaming up some really exciting experiments that we can do both on the radio and with everyone who comes. So do come along, everyone, because otherwise it's going to be a bit sad if it's just me trying to do these experiments. And we're going to answer lots of questions like this as well, and we'll hang around a little bit afterwards. So even once the show finishes, people can come and chat and we'll have a social, because it's a special year this year. It's 10 years, Eusebius, since we started doing all this. So we really want to do something a bit special.
It's been great fun. We will have great fun. Thank you. Thank you so much, Chris. Bring the kids along as well. It's lovely to get them infectious about the world of science from a young age as well. Go to www.702.co.za if you want to be part of the live audience for next week's special edition of The Naked Scientist on Thursday, which is going to kick off at about 10 o'clock. Just go to our website. Cheers, Chris. Travel safe. See you soon.
Thank you. See you next week, everybody. Bye-bye.